Hello, grade 11s. Welcome back. This is our last section for chapter 3. Yay, more quadratics. Today we're going to be looking at creating an equation given some information. So we've always been given the information, or we've had enough where we can make table of values, or we've been looking at parabolas. So here we're going to be making our own equation. So I give you information, or the textbook gives you information, and then your job is to come up with the quadratic equation that would match it. Again, you've got 3 different forms that you can use. You've got your vertex, your standard, and your factored form. So depending on the information they give you is going to change which quadratic equation you're going to pick to deal with. So a couple things to remember. If we give you x-intercepts, maybe a factored form would be better. If you can clearly see a vertex, maybe you might want to choose vertex form. So it'll depend kind of on the information that you have. Okay, we're going to look at 2 ways today. We'll look at doing it algebraically, and then we're going to look at using Desmos to help us out. And we're going to get Desmos to do the hard work. Okay? All right. Oh, there we go. Two options right there. This is typically the one we're going to look at, is your factored form of a quadratic. If we get into the other ones, that's fine too. Okay. All right. So let's quickly look at this one here. They've given us a beautiful curve. See, it's a nice curve. It's a nice quadratic. It's got a vertex. It's got x-intercepts. For our purposes, I'm going to show you one with the x-intercepts. It'll just be a little bit easier for us to look at. So to determine the equation in factored form, we need to write it like this, okay? This is our factored form. So when you look at it, we can see that our x-intercepts, it looks like the axis goes up by 2. So one x-intercept is at 2, and the other one is, let's see, 2, 4, and 6 right in the middle. That's probably 5. Okay, so let's just write down those numbers so we don't forget. So this one over here, it looks like x is at 2, and then the one over here, it looks like it's at, now not positive 5, it looks like it's at negative 5. Okay, so those are our x-intercepts. This is our r and s value, so we're going to plug those in. Okay, I'm going to do the writing on this side, and I'm sorry about the writing. It's not very smooth, but hopefully you can get the idea. Okay, so, whoops. Y is equal to a x minus r, x minus s. But I know that my r and my s value are negative 5 and positive 2. So y equals a. Now, it doesn't matter which one you put in first. Because I'm putting a negative number, when I minus a negative number, it's going to become positive. So this is going to be plus 5. Okay? And when I take positive 2 and I substitute it in here, we're going to have x minus 2. Okay. All right. So now I've got the start of this quadratic. Okay. This is good. I've got a good chunk of it done. The only thing I don't know is this a value. So I'm going to pick any other point up here, right? So step B, or part B, is to substitute any point you want into the function in order to figure out what a is. They gave me a beautiful vertex. I'm going to use the vertex, negative 124, in order to figure out what my a value is. Now, if I'm looking at my vertex, the x coordinate of my vertex is negative 1. The y coordinate is 24. So I'm going to take these 2 numbers and I'm going to plug them in for x and y in my equation. Okay, remember there's y over here. So instead of y, I'm going to plug in 24. I don't know what a is. I'm going to leave it alone. I'm just going to rewrite it. Now, x is negative 1. I'm going to put negative 1 where x is. I'm going to keep my plus sign. I'm going to keep my 5. I'm going to close that. Now I'm going to open up my next set of brackets. X was negative 1, so negative 1, and then minus 2. I'm going to keep my minus. I'm going to keep my 2. And now we can use our algebra to figure out what a is. So we're going to simplify inside each set of brackets, and then I'll figure out what a is. So this 24, I'm not doing anything to it. I'm just going to copy it down. Here it is. I don't know about my a yet. I'm going to leave it. I'll get to it eventually. Now, negative 1 plus 5, that's 4. I'm keeping my brackets, okay? Negative 1 minus 2, that's negative 3. Okay, looks a little bit better. Now I've got to figure out what A is. So I'm going to put these two together and then I'm going to bring them onto the other side. So I'm keeping the 24. I haven't touched it. There's my A. It can stay where it is. 4 times -3, that's -12. And I'm keeping this in brackets so I don't mix up a negative sign with a subtraction sign, okay? That's why I'm keeping it in a set of brackets. Now I have to get the A by itself. So I'm going to take -12 and bring it onto the other side. Because the A and the -12 are being multiplied, when you bring it over, you're going to do the opposite of multiplying. You're going to divide. So this is going to be 24 divided by -12, and that will equal A. Now I'm running out of room at the bottom, but 24 divided by -12, hopefully I can fit this in here. You should get -2 equals A. Okay, so we ended up with our A value. Okay, let me pop back on this side. Oops. There we go. Okay, and let's open up my pen. I just want to write down the final equation for you so you can see it all. Okay, so I've got y equals, I'm trying to write, remember, we're trying to write our equation. We're going to start in factored form. I just found my A value to be -2, so A equals -2. Now I should have x minus r, x minus s, but my r and my s values were supposed to be -5 and +2. Okay, remember over here when I plugged them in, when you subtract a negative number, it becomes a positive. So x plus 5 and x minus 2. And there is our equation in factored form. Okay, so determine the zeros, check, we did that. Put them into your factored form. Okay, we did that over here. Substitute any point. We took our vertex and we plugged it in for x and y. We got our A value. We took our A value and we just replaced A to get our entire form. Part D, if we wanted to write this in standard form now, we could distribute, right? Remember using your FOIL, and we could expand it. Okay, I can leave that up for you. Actually, you know what? We can do that right here just so you have it. So y equals -2 bracket x minus, x plus 5 and x minus 2. Here, let's make this large. Sorry, x minus 2, there we go. And the first thing that you're going to do when you are multiplying is you're going to expand your binomials first. You're going to do your distributive property. So in my brackets, I would have x squared, I'll fix that in a second, minus 5x plus 2x minus 10. Okay, let's just make this an x squared so it doesn't get us all confused. There we go. Okay. Then I can collect my like terms to get -3x. So let's just do this. -2 bracket. So there's the x squared minus 3x minus 10. And then our last step would be to take this -2 and multiply every term, or to distribute it into the brackets. So our final answer would be -2x squared minus 6x. Hold on, let me just put a square sign there. There we go. -2x squared minus 6x plus 10. Okay, oh, I made a mistake. So -2 times x squared is -2x squared. -2 times -3 is +6. There we go, +6x, and -2 times -10 is +20. Okay, so this is our standard form of the quadratic. This is our factored form of the quadratic, and you're done your question. Okay, all right, hang in there a little bit. Let's look at one more so you can go through all of this. If you have a table of values, life gets a lot easier because I'm going to show you with technology. You know what? We're in a technology world. Let's use our tools that we have. So I've got this table of values that we're going to look at. Okay. You've got it on your slide if you want. I don't need this one anymore. So this is what I'm looking at. So if you go to Desmos, okay, I'm just going to keep this down here so we can see the table. If you go to Desmos, one of the functions that it has is, instead of writing in an equation, you can put in a table. So hopefully at this point, if you need to pause the video, pause it. I'm going to plug in the plus sign. And if you scroll down, it says table. Okay, here's the X and here's the Y. My X values on my table were 0, 1, 2, 3, 4, and 5. And my Y values were 30, 50, 50, 60, 60, 50, and 30. Okay? So we've got this table going on. Now, I don't see anything on my graph yet because my values are so large. Like, I've got my X values from 0 to 5, but my Y values are 30 to 60. So I'm just going to slide over. I'm going to zoom out a bit. And eventually, oh, there's some points. I see them. There they are. Okay, so now I've got some values that I can see. And we want to create an equation. So, funky trick, okay? It's a quadratic. The standard form of a quadratic is y equals ax squared. Now, if you need to put the exponent, you can use the, I don't know, the little triangle hat symbol on the number 6 on your keyboard, and that'll put it up in the exponent. So ax squared plus bx plus c. Okay. Now, nothing happened. That's fine. I want my X values to come from my table. So my table has a little X1. So I'm going to put a little 1 next to my X. And it automatically knows that it's coming. Oh, hold on. Actually, this made a mistake. There we go. There we go. Hold on. X1. There it is. Put the 1 in first. Then do your exponent 2, okay? I'm going to put a little 1 beside this X, okay? And you should see those little subscripts. Still, nothing's happened. I want my Y value to be the Y value for my table. So I'm going to put a little 1 up there also. So just go beside the 1. Uh-oh, and something bad happened. My table erased. Don't worry, it's okay. I'm trying to get the computer to give me an equation, but it can't exactly equal. An equation can't exactly equal points, but they can approximately equal points. So we're going to use the squiggly line on your keyboard. Right beside your number 1 key on your keyboard, you should see that little squiggle. If you replace the equal sign with that, we get magic. And there's your parabola. So here's our parabola. This is your curve of best fit. Some grade 12 concepts here. So this is your regression for a quadratic equation. Cool, you're doing it now. And this just stops you from doing it by hand, okay? And just the terms are from grade 12. This is absolutely fine for you guys. So you get this beautiful parabola. It's called a regression. And the computer gives you the A, B, and C values. So your function would be y equals negative 5x squared plus 25x plus 30. Okay, so I'm going to write this down. I'm going to slide this over. Let's slide this over. Okay, and we'll just put this one down. I'll use my writing tool. There we go. So y equals ax squared plus bx plus c. This is our standard form. Oh. There it is. Oh, no, don't do that. Don't do that. There we go. There it is. So y equals ax squared plus bx plus c. Our a value would be -5. Our b value would be 25. And our c value would be 30. And voila, you have it in standard form, and there was no need for you to do any of the horrible algebra. Okay, so you can go into Desmos, use the squiggle sign instead of the equal sign, and make sure your x and your y values match the terms that are up in your table that you've listed. Okay, try some questions on your own. good luck, and your task will be posted online shortly. Good luck, guys.